today for this webinar on open technologies and open supply chains. So this is a topic that's a little bit different from usual, because this is not something that's so common to many buyers these days. But I felt it was interesting to provide people here some insight into the supply chain that you have in the digital sector, because we might see in the future more and more of these open technologies, open supply chain, also moving to other industry. I'm Hervé Legendre. I'm the EIPM professor, but also the director for the Value Creation Observatory, and it's a big pleasure to be with you today. So let me start. Let me start with a fairly interesting fact. So let's go back to April 2012. At that time, Facebook decided to acquire a company called Instagram. And Instagram at that time, they had 35 million users. So question is, how many people worked for Instagram when it was bought for $2 billion by Facebook at that time? And the figure is 13. 13 people all together in a startup were able to orchestrate a company that had 35 million users. So why? Well, simply because digital companies are leveraging what we call a lot of open source software and some cloud infrastructure. So basically, what you have here is a description of the technology that had been assembled in order to create something like Instagram. These are pieces of software that are open source software that were interconnected and run on top of a cloud computing services, which is Amazon Web Services. So this means that most of the code that was used for building Instagram was actually reused from other companies. And they just, added a few things, the layer on the top that was delivering, the features of Instagram. So this shows that in the world of digital companies, it's not just about make versus buy. There is a third option, which is about taking from the shelves and contributing later. Taking from the shelves, pieces of software that you can interconnect in order to build your infrastructure, in order to create your own service. And then, if your company grows, there's always the possibility for you to contribute back to this type of open source project. We'll go a little bit more into the details of all of this, but just to keep, see and look at that evolution. If you think of a company like Meta, Facebook, or Google, they started to be built around open source. They used Linux, they used Apache, MySQL, different languages. That's what we call the LAMP stack in software world. And all of these are open source foundations. And since that time, Google and Facebook, Meta, they've been contributing a huge amount of project to the world of open source. They've, in a company like Google, 9% of the employees have actually been contributing to an open source project. And I think in Meta, this is around, 900 open source projects, so 900 pieces of software that have been released for free for everyone to use, as long as, you agree to a certain license, and we'll come back on this. But then if you look at the next generation of companies, LinkedIn, Netflix, Lyft, Airbnb, I mean, all of them have been using open technologies that were coming from Meta, Google, Facebook, and after a while, they started to contribute themselves. So you've got like in LinkedIn, they've been contributing 75 open technologies. One of them is called Kafka. And Kafka is what helps to update all over the world all the streams on LinkedIn. And Kafka has been moved to a not-for-profit foundation that's managing contribution from many different sources in order to continue to develop this project. But also the project manager from the company in LinkedIn has started a company called Confluent, which is helping other companies to use Kafka in their own digital infrastructure. And today, 70% of Fortune 500 companies are actually using Kafka for their website. And the market capitalization of a company like Confluence, is 10.26 billion. So that's about, a tenth of a company like SAP. So this shows that what has happened over the past 10 years has been a blossoming of digital infrastructure as open technologies that can be used by anyone across any industry. Now, this type of way of doing business is really the opposite of what we are used to in the world of procurement. In the world of procurement, we're very used to what we describe here as the world of a pipeline. A world of pipeline is a world where resources, only one person can use it, and you can easily exclude anyone from accessing it. So you can have its property, and then only one company is going to pay for it. If you have a pieces of a book, like some of the ones I've got in front of me, one piece of book, there's only one person that can get access to it. But now, if I decide to put that book on the internet and to tell everyone that you can have free access to this book, as long as and you can do this with that book, and you have a very simple license to be able to use it, then the resource becomes something that can be used by everyone. And if one user access it, it doesn't prevent another user to access it. So that's a very different way to manage resources, get access to products, services, design that we have here. And I felt it was really interesting to be able to, share a little bit of information on how this works and how, from a procurement standpoint, we can look into this. And it's not just about software, because here you've got a picture that shows that the upper layer of the infrastructure of companies like Meta or Google, so they're made of software that are used to, deliver intelligence, artificial intelligence, that are used to create interface for the final user, or that are used to orchestrate, some of their software and run application on a cloud, for instance. But below that, you also have data centers. And data centers today, they run using open hardware. So the design of the data center are accessible online. You can go on the website of the Open Compute project, and you can have the design of all the racks, all the power components, and you can use that and get them manufactured by anyone you want. And today what we see as well for processors are full of software inside the processor that help the processor run and operate on a day-to-day basis. And all of this now is also more and more done in open source, thanks to a project that came out of Stanford a number of years ago called the RISC-V project. And even below, the world of telecom has evolved quite significantly over the past 10 years. And now, for the technology infrastructure in the world of telecom, we've got some projects like Open RAN from the Telecom Infra project that have been agreeing on open interface where it's very easy to mix and match different input from different suppliers. So what we see, and this was an initiative coming from Facebook in order to help connect more people to the technology, to the telecommunication technologies. So bring more people to the internet, especially in countries where, there's the infrastructure wasn't there yet. But now, this kind of infrastructure is used largely by a company like Vodafone in the UK. The Open RAN is deployed for 5G currently. So what we see here is these companies, the leaders from the digital world, instead of building proprietary resources that they own, that they control, instead of having the design of their data center or the operation of the data center, done by someone else, they do it themselves, and they share the technology that are used in it. Of course, because on one hand, this is not what creates their competitive advantage, which is on the top and on the surface, but also this brings them, a lot of benefits, in terms of the investment, in terms also of mastering the complete infrastructure, not experiencing anything that could slow down, their ability to deliver their solutions to a user, and not slowing down either their growth and their expansion in new sector. So that's a very different way to think about competition, to go into this type of world and to suddenly realize that, hey, there's a lot of elements that are free here. But, they don't do it just for the pleasure of making things for free to the others. There's plenty of good business decisions, and good reasons for doing this type of things. Huh? So let me go a bit further in terms of just to give you a sense of the magnitude of these things. So we talked about the data center today, and I'll do a case study on this one later. And we talked already about RISC-V you have at the bottom, which is, about a microprocessor. But think of artificial intelligence. We're talking about artificial intelligence today for a broad number of applications all around. Well, actually, the little engine that can train all the models that we use for building application. So, at the bottom, you've got these little engine frameworks. They are used to train models, and the models are used to build applications that we have in our processes, in our factories, in infrastructure, all over the world, in every industry now these days. Well, the little frameworks at the bottom, well, they're actually open source projects that have been released by companies like Google and Facebook. TensorFlow is the one that has been released in 2015 by Google, and 2017 Facebook released PyTorch. And, that's available for all the academics, for all the developers, that's available for everyone to use at any time. And because this was made available for everyone for free, this was very easy to quickly scale a large number of developers who were able to be trained on this technology. A large number of startups emerged out of it. A large number of consulting companies were able to take this technology, play with them, and suddenly develop some new offerings with it. So the power of having an open standard that's available to everyone and that can be freely used by a lot of companies on the top of it, this really accelerates the adoption of this type of new technology. We also talk a lot these days about cloud technology and cloud platforms. Well, actually, if you look into this aspect, now most of the cloud platform are running thanks to a software called Kubernetes. And Kubernetes was released 6-7 years ago, and this was initially started by Google, and then plenty of companies have, are now on board. There's a transfer of this project that took place, I think, around 15 to the Cloud CNCF, Cloud Native Computing Foundation. So this is a not-for-profit foundation, and the role of this foundation is to bring plenty of companies that are working together in developing not only Kubernetes, but now 98 projects. And if you look at the number of developers that are making contribution to this project, that's 137,000 people. So this is the equivalent of some of the largest, they're not full-time, huh? So this is the equivalent of some of the largest R&D companies, R&D teams that you can have in the world. And they've made altogether 6.8 million contributions. And as part of this network, you've got, hundreds of startups that have been, coming to the market and are helping companies to make use of cloud computing. So very impressive. This is not what we see when we look at the top of the surface, when we are on Google, on LinkedIn, or when we look at the software we use every day. But below that surface, there's a whole infrastructure, not only in terms of software, but also in terms of hardware, that's, made out of a lot of these open source projects. What are the benefits? So why are companies doing this type of things? So a first kind of work I did with some of my academic colleagues, Erko Otio and Ari-Pekka Ameri, was to do a lot of investigation on the motivation of companies like Google, Facebook, and others to do this type of things. So the first aspect, there's some very operational benefit to it. This is reducing the cost of developing this infrastructure, because if we share the benefit of using it, we also share the cost of developing it. There's a very strong element which is about to be attractive to developers, because when developers start their career, very often they start by reusing code from open source. And for them, this is really important to be able to contribute back at some point to open source. So this is really fundamental to attract and to motivate developers in the software world. They have, it's really important for them, the open source dimension. It's also a way for these companies to build their reputation and to enhance their software development capabilities. Now, there's also some, let's say, benefits that are shared across all the companies together. When you are dependent on one company to do some of your infrastructure projects, so a company like Google or Facebook, at some point they could have been, depending on HP, Cisco, or other company in order to build the infrastructure for their data center. But then, that would have created a massive dependency that would have impacted not only their cost, but their ability to scale and to develop really fast. So in this case, this eliminates bottlenecks. Technical bottlenecks, you can put a lot of resource to quickly solve problem, but also it's very useful to eliminate bottleneck in the tragic sense, so companies that control part of it. So companies like Google and Facebook, they see that as absolutely essential. They want to be the master of their destiny. But at the same time, being vertically integrated, having their own software stack, having their own data center, is something that, if they would design using proprietary resources, all of this, in a vertical integration mode, they wouldn't benefit from, all the innovation coming from other sources. So that's why, they operate this technology by themselves, but the design of it is totally open. So on one hand, they get the benefit from vertical integration. They master their destiny. They can develop their infrastructure in the direction they want at the speed they want without, feeling any kind of dependency on others. But they don't want just to be alone. They benefit from other companies who are creating other projects that you can assemble. And also by providing this project to startups, they create a lot of digital activities that end up benefiting to them. So that's part of the community, benefit we had identified. But also, there's plenty of ways to contribute to open source to undermine your competition. I'll share with you a simple case when, the world of maps and Google Maps is not an open source application. So basically, Google is owning all these maps, and they're making money out of all these maps by offering people advertising opportunities related to the use of these maps. And companies like Apple, till 2013, they were depending on Google for some of the maps in the world. So at some point, there was Amazon, Apple, and Facebook who decided to go and join a much more classic open source project where make of hobbyists, which was called the OpenStreetMaps. And they really help, by putting their technology, their staff, their people to complete a certain number of maps in OpenStreetMaps. It wasn't always seen as being a very nice way of moving in by the people working in OpenStreetMaps. But, this was a way of collaborating to develop an alternative to Google Maps. And, this is not today a major alternative, but we see it more and more on some websites. And a company like Apple is no more dependent on the Google Maps. They can use for some countries what's available within OpenStreetMaps, for instance. And by releasing some technology, like I've mentioned around artificial intelligence, you're blocking future competitors from moving in. So you establish your technology as the standard that's going to be used by everyone. And then, you're organizing the whole evolution of the technology around your own technology. And if you keep with the pace of evolution, this really creates for you a unique position where you can influence the evolution of the digital infrastructure. You can use also this type of open technology to enter into a new segment. So, for instance, in the US, Google has been working with medical institutions, large clinics, and they're providing them some open technology, some tools that help medical institutions, clinics, hospitals to combine in a single place all the data they've got on their patient. So this is regulated by a number of rules in terms of data privacy and elements like this. So, this is not connected to your Google account or anything like this. So there's a number of, regulation that prevent this type of things to happen. But the big point is, before in hospitals, you would go at the reception, your data would be in one database. Then you would go into the, taking a scanner, all the information, including, the scans, would be in another database. And these open systems allow us to collect and put together all of this data. And then they've developed something that they sell, which is an artificial intelligence engine that can scan all of this data. And by looking at tons and tons of patients, that can start to predict out of this big mass of information what might happen to a patient, because this can identify patterns that, we might not be able to, predictions that we might not be able to see usually when all the data is closed and siloed. So that's a way for companies to move into a new sector by providing some of the infrastructure to companies in that sector, and then, being able to deliver, for instance, AI capabilities in order to make this happen. So we see the benefits are multidimensional. First, it looks like, oh, I'm happy to share my technology with everyone. But first, there's a positive cost dimension to it. Second, there's a lot of operational reputation benefit that you can get out of it. It allows to eliminate all the bottlenecks across the industry, little by little. And in some occasion, this is really helping you to gain some, competitive advantage by eliminating dependence on competition or creating new opportunities into new segments. So that's what we need to have in mind. And nowadays, we start to see companies in the automotive sector, like Robert Bosch, that are investing a lot in these open technologies because they realize to be a key player in the world of IoT, this is something they need to move into. Okay, so that was a little bit about the introduction and helping all of you, I hope, to get some understanding of what is it that we're talking about and what is it that we mean when we talk about this type of open technologies. And I haven't started to talk really about open supply chain. So for software, yes, there are supply chains about data. Yes, there's different players working to build the software, but I wanted to share two case studies related to hardware. So this is the kind of project that's not just about software, but also, include some of the stuff you see here. So that's in a data center where you've got all these racks, and in all these racks you're going to get some processors, and all of this will be with a lot of electrical components, and there will be also some cooling system on top of this. So huge places where you've got a lot of these components that are used to process all the data, run application, and so on and so on. So today, that's about 190 companies that are working together. So a very large-scale collaboration, 5,000 experts. And just to give you a sense, within a few minutes, a few years ago, I've registered and I joined the community of the people that are designing racks. And every week, I'm receiving emails where all the engineers who are working on the racks are exchanging information. And on a regular basis, there's a meeting online where people have discussions. And all of these meetings are recorded, and all the decisions are available. So I can access all of this. I didn't pay anything. I didn't need to demonstrate I was an expert in the field. I really joined these communities. And I can get access, don't even need to be part of this community, but anyone can get access to the design of all the components that you see on these. It was started in, the idea came from Facebook. It was started in 2012 when they put together a foundation, a not-for-profit organization, to manage this large-scale collaboration. Over the first years, I would say the focus was what they call vanity-free design, so making sure that we can eliminate everything that's going to create some extra cost. So, it's not like painted in black. There's no, floor ceiling that looks great. This is basically getting to a point where the design is the cheapest possible, the most operational possible, and everything is super easy to assemble and interconnect from an operation point of view. So the first focus was on cost, was on ensuring that for all these components, there wouldn't be one supplier that would take this open design and be able to produce all these components, but there would be a few suppliers, so there would never be in a situation of dependency from a supplier. And then over time, this moved into other type of features. So there was a focus on energy efficiency, for instance, designing the system in such a way that you can eliminate some of the bad usage of energy, or find a way of reusing the energy, the heating produced. Company kept joining. companies like Apple and Microsoft have been joining the Open Compute project, and they've been contributing some of their design to the whole pack that already existed. And Google also joined, and they're now on the board of the foundation, and they've started to contribute complete design of some of their technology. So more and more companies also from China have been joining. And recently, there's been a very strong focus on new ways of addressing some of the decarbonation and some of the sustainability challenge. I've been writing together with one of the manager of the foundation, Steve Elvey, an article published in the European Business Review recently. So if you're interested to know more about this, just drop me a mail and I'll be happy to send you this article and some of the other articles I've been writing on the topic. So what is this point about sustainability? So now you think you have technology that's common to all of these companies, and you have a perfect standard. You can mix and match, the different components from different suppliers to build this type of data center. And one company, IT Renew, came into the game and said, what we can do is we can help to manage a circular economy process. So basically, companies like Meta or Google will be the first one to use the latest, components, the latest technology coming out of the OCP. And so the first batch and the big volumes at the beginning will be ordered by their company. And a few years after, they'll want to switch, to the next generation of technology that are getting better every time. And what they do now is they can provide all these components to IT Renew. IT Renew has a technology that's used to erase all data, from the drives, for instance. And then, these blocks of technology can be sold on a second market and can be used by other companies who have technology that's the equivalent of a year and a half from the latest trend, that latest version that exists on the market, and they can benefit from reduced price, and the whole thing allows to reduce some of the impact in terms of CO2. And you've got very impressive figures. This lead to a reduction in terms of a total cost of around 40%, reduce the embodied CO2 by 52%. So embodied CO2, it's why inside the components. So that's Scope 3 upstream CO2. And then the operational consumption. So whenever you use this component, this helps to reduce by 20%. And big impact in terms. So I've put a link to a video that describes the circular logic that has been implemented. So you see the benefit here is not simply to have something low cost, but then this is an open architecture where you can mix and match whatever element that is important to you, and therefore you can reuse that and bring that back to a good state and extend the life of the equipment and have all these benefits, both in terms of TCO for the next user, but also in terms of CO2 impact. Going even further, this really helps companies, big companies, and I'll take the example of Alibaba Cloud. I was in a conference organized by people in Asia not long ago with the purchasing leader from Alibaba Cloud. So here, I'm going to talk about the processor, and we'll come back on RISCV, but the processor that goes into all these racks, and then everything goes into a data center. And basically, Alibaba Cloud business, they've operating their own company, which is designing with open technologies this processor. And they're buying directly this processor from foundry company who's making processors. And then this gives them visibility on their complete supply chain, because they provide the processor to their supplier that are integrating this processor into all the elements that are going into the data center. So by designing and controlling the early stage of the supply chain, this gives them really the opportunity to monitor, at what stage all of their processors are, and having a full control, full visibility from a supply chain point of view. So that's one of the very interesting elements that allows you to invest in developing some of your technology. You don't need to manufacture. This can be, given to a traditional supplier, manufacturer of this element, but that helps you to have full visibility on the supply chain from the beginning to the end, because you're active on both sides. So I thought it was an interesting dimension that I would need to emphasize here. So what does it mean in terms of the evolution of our supply chain and industries? So the way we see most of the time, an industry is we have our company who's focusing on creating value that will be, and it will be sold to clients. And we integrate different technology together, and we deliver the benefit to the final user. And that's what you have on the right here. But then if we look at creating new technology that are embedded into these products and services, very often we design some of this technology that we own. We ask some of the supplier to deliver us some of their technology where they've been doing themselves the innovation and where they own the innovation and they have a patent and all of these things. And for us in procurement, this is sometimes a battle we have here, because there's some form of dependency emerging here. And sometimes, these new technology from other sources like R&D centers or other sources. And here we're moving to the picture at the bottom, where we still have this technology integration that's going to put together all of these systems, deliver to the client the final product. But before, upstream, in the technology creation part, in fact, all of the actors are coming together, forming a consortium, participating in this not-for-profit foundation, and working together to develop standard technology that can be used by everyone within the industry. And, this is really creating this kind of bottleneck-free type of environment, but also because you have somehow a situation where everybody's working on improving, the foundation technology everybody's using. You can get a lot of improvement going on. Do we have a question, Frederic? I've got Frederic helping me today to run the... is there a question in the chat? So yeah, we've got a question. Did Alibaba develop their processor, or did they obtain them from independent supplier? So, in fact, in the case of Alibaba, they bought a company a few years ago called Pintuch, which is a company who's designing what's inside a processor. And the more we go into the advanced processor, the more we have software in it that can help run a processor. And when you buy a microprocessor, there's always already a lot of software inside it. So they have a company that's owned by Alibaba that's doing the design. Now, that company is using a number of tools. Some of them are open technologies. You can, get access to them on GitHub or other repositories. And potentially, there's also some IP, pieces of software, I don't know, for security, where part of it is open and part of it you need to pay some fees because, not everything is going to be free. For companies to be able to make money in this world, very often you have a core of the project that's free, and startups or company, they build complements to it. They build a service, they build a tool, or they build additional element that helps to justify the fact that they are going to be selling something to the final user. So there's never a case where everything is totally free, but there's very often a case where the core of the technology is accessible in the lower layer of the infrastructure. And after, you can pay for some of the complements. But some of the companies, like in the case I've mentioned before, like Western Digital, they've been developing their own processor, and now they've released the full processor, the full core under an open source license. So what happened is, over time, there's if the project goes in the right direction, there will be evolution where more and more of the technology will be available openly and accessible to everyone. So this is one business model you can have, but not all companies, would have the ability and a business case to invest into a microprocessor designer company. And other companies have, in this case, relied on a number of startup or small companies that have been emerging as the integrator. I mean, small companies. One of them is already a unicorn, Sci5, and they're able to design for you the exact processor you need, especially for embedded application, IoT application, AI. So things that are a bit different from a standard processor, where you can expect some very special features that can really add value to you and allow you to control the chain from the beginning to the end. So long answer, but this is taking us to the next topic. I hope that was clear. So now case study number 2 is exactly the one I was talking about. This is RISC-V, and what we see here is we've got the picture, showing us the evolution in terms of the adoption of RISC-V. So today, whenever you buy a processor, most of them will be based on a standard, which is called x86, which was brought to the market by Intel and was used by, is also sold by AMD, for instance. And this is one way of running the foundation layers inside a processor. And the other one is ARM. And ARM, let's say, has been conquering the market for mobile phones. And the x86 is more into computer and servers. And a few years ago, within Stanford, the university in the US, a project was started between a professor and a bunch of students, and they say, we are upset simply because we can't design our own processor as academic. All the intellectual property is owned by Intel or by ARM, and we can't have any possibility of using this to experiment and build new things. So we are going to develop a new open standard for processors. Some existed, but they never managed to get a lot of market share. And the project started 2010, I think. And then in 2015, they had put the project in the open, accessible to everyone. And they started to see a lot of companies interested by RISC-V. They didn't want to talk too much about it because most of the companies that moved to the RISC-V ecosystem used to be working with ARM and using the licenses from ARM to build their own processor. But they didn't want ARM to know they were working on RISC-V. So there was a period where everything was happening in stealth mode, not telling too much, but the whole industry was coming onto RISC-V in order to, develop this new foundation in terms of software for processor. And one person I've interviewed recently, described this as the democracy of silicon. He says, up to now, only very, very few people have been able to contribute to the design of semiconductors. And now, by having this open source, first, this allows anyone in the world to be educated and to be able to design their own processor. And he says, this is going to drive some very interesting innovation in the future for processors. The second element, it's also very important from what we call today a technology sovereignty point of view. Many people have seen what has happened in terms of the trade war between the US and China. And like in India, there's a big fear about one day not being able to get processor that would be designed in India. End of the day, anyone can put pieces of software in this processor, and then you can end up in a situation where, all of your telecommunication infrastructure will be sending some information to some of your enemies. So, this is about achieving sovereignty for interest of some nation. This is about creating some economic independence at the level of some state. So the implication, of this open technology are going quite far in terms of, the impact on the evolution of the industries across the world. In 2019, there was an article in The Economist that was publicly saying, hey, you know what? This is one of the competitor of ARM, and they should be paying attention to it. Today, they've got 2,000 members. It's really like blossoming. And why? Because we've reached some of the limits of Moore's law. So it will be more and more difficult to do more powerful processor into the future because we are reaching the limits of physics. And at the same time, we need different types of processor. Some of them can be, like if you want to send something to, I don't know, in a satellite, you really need a processor that's going to consume very little amount in terms of energy. So that's an application where you want to be able to go in the code, eliminate everything that's not necessary, so you have very low consuming. But bigger application, if you take artificial intelligence, this is a totally different way of making calculation. It's not like our classic, calculator where we had multiply, subtract. It's actually tensors. We have these, these big matrices that are being multiplied and combined. And the point here is not to be super efficient in terms of, the precision, but it's to be able to compute, these big algebraic operations. And that's a totally different way of, structuring the basic way of doing things inside a processor. And if you have access to the most basic code that's inside the processor, you can then specialize it to deliver some of this. And you can look onto this document and you can see a lot of applications that are very specific for IoT, for AI, and for other type of application here. So, I never told you for the time being how I got involved in the whole story. So actually, this was a company that was in the defense and in the electronic industry, defense electronics, that back in 2017 was asking the procurement team of the company, we would like you to help us to assess if we should be joining the RISCV bandwagon, join that ecosystem, because tomorrow we would want to leverage this as a supply chain, because you've got all this community with all this company building tools and components that are going inside this processor. A lot of it is free, but some of it you need to pay for. And at the end, if you're designing your own processor, you want to have a supply chain that's going to be delivering this to you. And that was a pretty new topic, because in procurement, we are very used to qualify a supplier, but we are not so, used to qualify an ecosystem, qualify an expanding group of companies that are working together to deliver something in the open that can be used. And at that time, this is what we did. We consulted a number of companies to try to understand the total cost that was at stake. We look into some of the licensing aspects because you want to have licenses that allow you to build something for free on top of it. We look at the modularity, the stability, and how much this would allow you to easily design something on the top. We looked at the impact in terms of timing of innovation that we would be able to deliver. We needed to understand, the health of the ecosystem, if this is something that will continue to develop into the future, and so on and so on. So it was very interesting because I, coached a group of people that were helping the R&D team to understand, would this be a good option into the future? But it wasn't about assessing a supplier. It was assessing an ecosystem that was developing with all this technology. And that's what got me, into this type of a project and when I started to look more into these things. So that's, if you want, all the type of companies that are part of the RISC-V ecosystems. Some of them, manufacture the processor. Some of them develop some of the tools. Some of them develop, what we call IP blocks, like something that's doing control in the processor, making sure there's, nothing going wrong. Some of them do security inside the processor, and so on and so on. And you've got big companies that are using that to design their own, and you've got other company that can rely on an integrator, a company who's going to design the processor for you. So that's part of this ecosystem that some of the supply chain are, finding their way forward and becoming more important. So how do we qualify an ecosystem of open technology? That's really a question that I think is important from a procurement standpoint. So you remember, I've just showed that to you. And I'm going to try to highlight some of the important points. So I'm not going to go through every steps. Actually, the study that we did, we turned that into an article that we publish in Research and Technology Management. And that tells the story of how Thales has been able to, has been adopting RISC-V. And again, if you contact me, I can give you access to this article, no problem. So first step, I would say, is really to understand, the different dimensions: TCO impact, innovation impact, performance, stability, and modularity. So what we want is to start to have a look at, what are the big advantages and what are the main risks associated to this technology. And you have here, you can consult a number of companies in order to start to compute a TCO impact. You can look at how much would it cost to change from one technology to another. You can look at what it would mean in terms of impact on innovation speed. So here, I've been listing a number of questions that, I've been using in a number of times in order to understand, how interesting it would be to join an ecosystem or another. And some of them are, very basic in terms of stability, modularity. So do we have a stable solution? Are all the players working on the same technology? Or do we have like a technology that's fragmenting and a multiplication of players that are taking their own, the project and changing it into something different? That's one of the risks in this field, is to have this fragmentation. Sometimes it has benefits, but very often, especially, whenever this goes into a processor, this can be a big issue. And how easy it is to interface with other stuff. Second point, it's really important to understand the licenses. So in the world of open source software, there is something where some of the licenses are permissive. So what does it mean? A permissive license is a license that says you can use it, and you can use it to study it, you can use it to implement it in your system, but you can also use the technology to build your own product, and this product you can sell them without any problem. Other licenses that are being put to them on the market some years ago already, they have some contamination effect. So if you're using a block of technology, whatever you do on top of it, you don't have the possibility, you need to make everything available to everyone. So if you use an open technology, whatever you develop on top becomes in the open. So from a business standpoint, you really need to have this permissive license that free you from any situation where you would be constrained to sell something on top of this technology. And this is a whole business, I would say, a whole profession of understanding all of these licenses. Huh? There's even one license who says you can use freely my software, but if you meet me at a conference, just make sure you buy me a beer one day. So this has a name, it's like buy me a beer license. Some companies say we don't want to use this one. In Google, you can't use any software that's coming from buy me a beer license. And other company says, okay, that's fine. This is not a big issue from a legal standpoint. So it's a whole world of understanding these licenses. It goes through some legal teams, but that's really important to make sure that you've got the freedom to build a business on top of this technology, which is the case with OCP and the case with RISCV, for instance, because in order for this technology to develop, that's a necessity to have that in place. Then there's a third point you need to pay attention. So yeah, that was the second point. The third point is really to understand the health and the viability of the project. Huh? So there's a number of dimensions that you can look. Who is orchestrating the ecosystem? Is that a single company, a startup who's put their project open source and they're selling that services on top of that technology? So here, that's a situation where immediately, there's only one actor who's a startup who's released that, and they're selling something on top. So that takes you into other questions to be able to understand if that can be a challenge or not. If you see the case of Kafka being used by 70% of Fortune 500 companies, today there's more than one company that can help you to implement that project into your system, it will be fine. Huh? But in other occasion, you'll start to be concerned about, some form of dependencies or the project to not be viable and disappear at some point. When you have a situation where there's a not-for-profit foundation, where, the foundation is really here to protect the interest of the users and the company participating into it, if you have a project where there's, a growing number of projects, a growing number of contributors to it, you start to see that this is a very serious project that you can leverage and that you can use in your own development. So that becomes something really interesting for you. And finally, you need to understand, do we have suppliers who can help us to integrate that technology? Or would we do it ourselves? But if we do it ourselves, do we have the skills? Or do we have profiles available on the market? Or if we have an integrator, are they fitting our use case and the needs we have? Because that might be fine for a company like Google or Facebook, but maybe for our own application, we need something, we need an integrator, and are we going to raise their interest? Will they want to work for us? So this is really important here from a procurement point of view, that we're able to contribute to this assessment and have this, complete TCO impact and analysis of potential dependencies. End of the day, if you have a viable project and the ability to implement it, either internally or by leveraging some of the integrator, this is a safe choice. And if the advantage are there in terms of cost and innovation, go for it. If you have a situation where the project, there's question about the viability, try to understand what would be the what-if scenarios. Can you easily switch? These type of things. And if, the project is very viable, but you're not sure about the ability to implement, here you really need to look at the multiplicity of integrator that can help you implement it and really carefully qualify the integrator so you make sure that you've got some stable ways of implementing the solution or not. So you would be spending more time looking into this. And if the project is not so viable and you don't have really integrators that can help you to implement it, or you don't have the skills, well, then it's best to avoid this type of project. Huh? So this is, a few hints that you can use. There's a method that you can follow. It's nearly all described here in order to look into these opportunities. I hope this helps you to discover, maybe a new side of the digital world, not the one that happened on top, on the software we use, on the platform, but how, supply chain deliver this type of infrastructure, and how much all of this is built on open technologies. And potentially, as we see all that going into automotive, healthcare, there'll be more and more of this ecosystem that will be coming our way in other sector. And I thought it would be interesting to share all of this information with you. I hope you enjoyed it. Don't hesitate, to come back to me if you've got more questions. I've got a little research project going on with a few people from Imperial College in London and from the University of Lausanne. And we're working on this because we think it's really interesting, a bit different from what we see. And I think it's worth sharing this point with procurement, because very often, every time we hear open source, we are afraid. But, it works for this company. So we need to understand when it works for us and when it's not going to work for us. So thanks a lot for being with us this morning for this webinar. I'm still available for questions. We're running out of time. But, you can also contact me, and we can discuss offline out of this. I hope that was interesting. Fred, I think we've got some.
Yes, some questions. Okay, no.
Very interesting, worth attending. Thank you. Thank you, Delphine. So, goodbye, everyone. Have a great day, and never hesitate